Another calculating quantities question here, again with a bit of a twist and tell. But calculating quantities questions all have 3 stages. So first stage is moles, second stage is stoichiometry, and third stage is moles. So even if you don't get the sting in the tail, hopefully you can get these 3 stages, which will be most of the marks for a question like this. This will be a 4-mark question. So it says 15.9 grams copper oxide. Let's write that on top of the copper oxide there, 15.9 grams. So we've got a mass of copper oxide. 15.9 grams copper oxide completely reacted with 500 centimetre cubed. 500 centimetre cubed. Now it says completely reacted, so we can assume that's an excess, so we can essentially cross it out of the equation for the stoichiometry stage. Calculate the concentration, so we need concentration here, and we want that in grams per decimetre cubed. And there's a sting in the tail, because a normal moles calculation will do the concentration in moles per decimetre cubed, so we're going to have to convert that at the end. Anyway, 3 stages to the calculation. Moles, stoichiometry moles. First stage, moles. We need to calculate moles of copper oxide. For that, we've got a mass of copper oxide, so we're going to need the moles equation. Moles equals mass over formula mass. Mass 15.9 grams divided by the formula mass. Now we're given the formula mass here, we don't need to calculate it. We're given the formula mass of copper oxide 79.5. That looks like 0.2 of a mole to my mind, but you can check it on your calculators, which will be a good thing because my mental maths isn't always right. Okay, so stoichiometry, we've got copper oxide. There's no number before the copper oxide, so we can assume it's a 1, okay, because if there's never a number there, it's always a big number 1. We've got at least 1 because we bother to write CuO out. And that's going to make, we'll cross that sulfuric acid, it's going to make, and there's no number before the copper sulfate, so there's 1 copper sulfate there. So our stoichiometry is quite easy here. 1 makes 1. It's the same, so we can write same on top of that arrow. Now we don't have 1 mole of copper oxide, we've calculated we've got 0.2 of a mole. So we're going to make the same. Whatever we happened to these numbers here has to happen to these numbers down here. 0.2 of a mole copper sulfate. Okay, so we now want concentration. So we need a moles equation with concentration. That is going to be moles equals volume divided by 1,000 times concentration. And concentration here, this will be in moles per decimetre cubed. Okay, so moles, we said was, what did we say that was? We said that was 0.2. So 0.2 equals 500 divided by 1,000 multiplied by the concentration. Concentration is the question mark in this case. So I'm just going to work 500 divided by 1,000 out to make it a little bit easier for me to rearrange. 0.2 equals 0.5 times our question mark. So 0.2 divided by 0.5 equals our concentration. That's 2/5, so that's going to be 0.4 mole per decimetre cubed. Again, check my maths, but I think that's right, I've done that in my head. Okay, so that's in moles per decimetre cubed. Okay, that's in moles per decimetre cubed. We need it in grams per decimetre cubed. Now, because we're comparing a mole per decimetre cubed to a gram in a decimetre cubed, we're comparing the same volume. So this is where this equation comes back in now. So to move from moles to mass, because that's what we're doing, we're moving from moles per decimetre cubed to grams, which is a mass in a decimetre cubed, we can use that. So we've got moles and we want mass, so we're going to have to make mass a subject there. So mass equals moles times the formula mass of our copper sulfate. Our formula mass of copper sulfate, 159.5. And we've got 0.4 moles. Well, because you were checking my maths with your calculators, you got your calculator out. You can do that yourself, but 0.1 of that will be 16, so 4 16s is going to be about 64. If you're not getting an answer about 64 grams in a decimetre cubed, then your calculator use needs a bit of checking. All these questions on oceanhighchemistry.com.